All right, so today we are going to talk about the first two chapters, first two sections of the first unit of this course, chapter 2 and 3 from the textbook. As I mentioned the other day, we will not be using the textbook. The notes and stuff will be based on what's in the textbook. And these two chapters will kind of form a foundation for the rest of this stats course. So let's get started. Okay. Data is the foundation for statistics. Data can be anything. It can be numbers, it can be names, it can be labels, anything that's collected for the purpose of making predictions can be considered data. But one thing that we'll learn a lot moving forward is that it's useless without the context. We see this all the time in society today. Numbers can be spun to make any point. So if you're not providing context when you're citing data, it's not going to mean much. And what do I mean by context? I mean the classic who, what, when, where, why, and how. So data can be anything, but you need the context in order for it to actually mean something. Okay. There are two special types of data that we're going to focus on these first couple of chapters here. We have categorical data or categorical variables and quantitative variables. And those definitions are pretty self-explanatory. They're kind of implied in the name. A categorical variable or categorical data. Categorical sounds like categories. So any type of data that falls into categories is considered a categorical variable or categorical data. These are just some examples that I came up with. Coach in first class on an airplane, marital status, type of car that you drive. Those are all things, those are all data points that are not measured. They're categories. So those are categorical variables. Whereas a quantitative variable, quantitative sounds like quantity. A quantitative variable, quantitative data is data that is measured. Anything that has to be measured and has units is considered quantitative in nature. So, for example, your height is something that is measured. Your shoe size is something that can be measured. Those are examples of quantitative variables. For today's presentation, we are going to focus solely on categorical data, categorical variables. The next presentation, we will focus on ways of displaying quantitative variables, but it's still important that we understand the difference between the two. But like I said, we are going to focus on categorical variables today, data that falls into categories. Okay. So our first example of a way to display categorical data is a pie chart, and a pie chart is exactly what it sounds like. Each category falls into a slice of the pie, per se. This is an example that I took from the textbook. I believe this is a breakdown of the people that were on the Titanic when it sank. So we have first class, second class, third class, and crew. You can see with a pie chart, not only can you compare each category to each other, to the size of the other categories, you could also compare it to the whole because each category is a slice of the pie. So a pie chart shows a general comparison between each group, how they compare to each other, but it also compares each group to the whole because each group is a slice of the pie. So that is a pie chart. The next one is a bar chart or a bar graph. And again, a bar chart or bar graph is exactly what it sounds like. This is the same exact data from the previous slide, but instead of a pie chart, we have a bar chart. Okay. Again, a bar chart or a bar graph shows us how each group or how each category compares to each other. So we can see how first class compares to second class, which compares to third class, which compares to crew. We can see how they compare to each other, but we can't see how they compare to the whole because each bar is separate. It's not part of that one whole pie. So it's just another way of displaying the data. Notice in a bar chart or a bar graph, notice the bars are not connected, they're not touching each other. One of the things we'll learn about in our next presentation is something called a histogram. And you might remember in a histogram, the bars are connected, are touching each other. In a bar chart, they are not. Okay? And kind of as an offshoot of a bar chart or a bar graph is what we call a relative frequency bar chart. And a relative frequency bar chart looks exactly the same as a regular one. You can see these look exactly the same. The only difference being is in a regular bar chart, the breakdown is by count. So we can see that, for example, first class had, if we estimate, maybe 300 people. Second class had a little bit less than that. Okay, that's a regular bar chart. In a relative frequency bar chart, the breakdown, instead of by count, the breakdown is by percentage. Okay, so for example, first class was, if we estimate, maybe about 15% of the entire number of people that were on the Titanic. Second class is obviously less than that, so on and so forth. That is literally the only difference. They look exactly the same. The only difference is instead of breaking it down by count, we break it down by percentage. Okay. Next, we have frequency tables. Okay, excuse me, a frequency table shows the exact count. So you see here, it gives you the exact count for the number of people that were in first class, the number of people that were in second class, so on and so forth. It also gives us a total. Sometimes the total is given, sometimes it's not. Sometimes you have to use a calculator to find the total. And we use a frequency table to find the relative frequency. And this is something that you will do on your first assignment. So I wanted to show you an example here. So we use frequency tables to find relative frequency. Relative frequency is just a fancy word for percentage. Okay. So I did a breakdown here. If I had asked you find the relative frequency for the number of people in first class, all I did was I did 325 out of the total number of people, 2,201. And you can see it was approximately 14.77%. I just did that on a calculator. Same thing with second class, third class, so on and so forth. So when you are asked to find the relative frequency, it is just a fancy way of saying find the percentage of all people that were in first class. Find the percentage or relative frequency of people that were in second class, so on and so forth. Okay, so that is why we use frequency tables. Next, we have something called a contingency table or a two-way table. And the main difference is and this is the reason why it's sometimes referred to as a two-way table. A contingency table compares two different categorical variables. So in this particular case, it not only gives you the breakdown for first class, second class, third class crew, it also gives a second categorical variable of whether they survived the sinking or whether they died. So in this particular example here, the two categorical variables are what class they were in, first, second, third crew, and whether they survived or not, their survival. Okay, so that is what a contingency or a two-way table is. And something I'll note again in this particular example, which I stole from the textbook, notice the totals were all given. Sometimes they're not. Sometimes you will have to find these tables, and you'll see that in your first assignment on these chapters that you'll have to total out each row, each column, and also find an overall total here. We use contingency tables or two-way tables to find specific percentages, and I'm going to show you an example of what you'll see in your assignment. One thing you'll learn as we go through this course is not only will I go through notes, but I'll also go through examples so that you'll have something to go off of when you're working on your assignments for this class. So when we're finding specific percentages, you want to look for the word of. Okay, the word of will tell you which total goes in the denominator, and then it'll also tell you which column or row to look at. So here's a couple of examples. Okay, what percent of people on the boat stayed alive? So they are asking what percent of all people on the boat stayed alive. Okay. So in this particular case, out of the 2,201 total people that were on the boat, out of that people, 711 of them survived. So the way we find the answer is by simply dividing that out. Okay, and you can see it was a little bit more than 32%. Okay. Next example, what percent of people who died on the boat were from first class? Okay, so notice after the word of, it's what percent of people who died on the boat. So out of the 1,490 people, out of those people who died, 122 of them were from first class. So those are the two numbers that we're going to divide. And you can see it came out to a little bit more than 8%. So the key is look for the word of, and that's going to tell you what total goes in the denominator. Here's another example. What percent of first-class passengers stayed alive? So if I look after the word of what percent of first-class passengers? So out of 325 total first-class passengers, 203 of them survived. So 203 out of 325 first-class passengers survived. So that's more between 62 and 63%. Okay. So that is what we use a contingency table for, and there will be numerous examples of this on your first assignment. Okay. Next, we have the other thing we use contingency tables for, something called a marginal distribution. A marginal distribution, if you think of the word margins, a marginal distribution is what it says it is. It's a percent breakdown along the margins. So here is an example I did here. I did a breakdown along the rightmost margin here. So the way we would describe this is we would say that the marginal distribution for survival, so out of all of the people, 32% survived and 67.7% died. That's what we would say is the marginal distribution for survival. And likewise, I could also do a marginal distribution at the bottom here. Okay. So I could say that my marginal distribution for class, okay, and I did this breakdown here, and I could say that out of all the people on the boat, about 14, 15% were from first class, about 13% were from second class, third class, crew, so on and so forth. So a marginal distribution is simply a breakdown along the margin. So the marginal distribution, in this case, we did a marginal distribution for survival, whether they survived or they died on the Titanic. And then we did a marginal distribution for what class they were in, first, second, third, or crew. The last thing we'll talk about in this presentation is something that you'll see that we'll come back to a lot throughout this course, and that is this concept of correlation does not prove causation. And this is kind of like this is also a basic foundation for statistics. When we look at data, when we analyze data, okay, we may see that two things appear to show a relationship. Okay, like for example, the data in the previous slides may appear to show that the higher class you were in, the more likely you survived. Okay, and the data appears to show that relationship. That's what we call a correlation. A correlation, a relationship, is a lot different than a cause effect. Okay, just because two things may be related doesn't mean that one thing directly causes the other. Okay, so just because the data appears to show that the higher the class you were in, the more likely you survived, does not mean that one thing directly caused the other. Okay, simply being in first class did not directly cause you to survive or die. There were obviously other factors in play. Okay. So just because two things appear to be related, it does not mean that one thing directly causes the other. In stats, and really in science in general, if you want to prove a cause-effect relationship, it could only be proven with a scientific experiment. And when I say a scientific experiment, I mean like the scientific method that you talked about in science class. Okay, so when you hear correlation does not prove causation, that's what that means. Okay, just because data may show that they are related does not mean that one thing directly causes the other. There are very often other factors, other variables in play. Okay, that is it for this first section of the course. For these first two chapters. Your assignment will be on Edulastic, and I will share that with you via Google Classroom.